Good afternoon, everyone. This is Chris Dalsky from National Weather Service Eastern Region Headquarters. And this afternoon for our NWS Climate Services Seminar Series, we're going to be discussing Mesonets. We have two guest speakers that will be presenting here. So they're both going to talk, and then after they're done, we'll take time for questions and answers at the end after both presenters are done. Our first presenter is Dr. Curtis Marshall. Dr. Curtis Marshall directs the Commercial Observations Portfolio for the NWS Office of Observations. The portfolio includes the National Mesonet Program, the Aircraft-Based Observations Program, and the Meteorological Assimilation Data Ingest System, also known as MADIS. Prior to returning to the NWS in 2009, he was a staff scientist at the National Academy of Sciences, where he directed the study that recommended the establishment of the National Mesonet Program in NWS. His background and expertise are in observing systems and applications to numerical weather prediction. He holds BS and MS degrees in meteorology from the University of Oklahoma and a Ph.D. in atmospheric science from Colorado State University. So Dr. Marshall, take it away.
Thank you. Thank you for the introduction, and thank you for the invitation. I'm pleased to be with you all here today. If you could go to the next slide, please. I understood in some of the email conversation and setting up the meeting that there's quite a bit of field participation in these webinars. So I wanted to take a moment just to introduce the National Mesonet Program broadly before I get into some specifics and examples of how it could potentially be used in weather service, climate services and products. So the latest iteration of the National Mesonet, it's been tried before for over, 2 decades, arises from this Academy's report, which was mentioned in my introduction, that was released in 2008 from the ground up, as it's known as. And it provided a series of recommendations to the Weather Service, NOAA, NASA, EPA, other agencies, and the Congress about how to build out a really comprehensive nationwide mesoscale observing capability to meet and match the resolution of storm scale numerical modeling that had evolved by that time. I think, as we all know, most storm scale or mesoscale models these days are running at resolutions of just a few kilometers, but our observing systems assets are nowhere near providing the observations needed to provide the initial conditions at those sorts of resolutions. So that study recommended how to go about that, both with the technology, the science, as well as how to manage it as a program in the federal government and in other sectors. Now, it was about much more than just this question of mesonet, which is what most of us think of when we use that word. We think of a surface-based observing network operated by a state. But on that specific question, what the committee recommended is that the federal government should not seek to build out a federally owned and operated observing systems capability for a national mesonet, because by that time the states and the private sector were rapidly emulating the Oklahoma model, building out a lot of state networks nationwide, as well as some private companies with a nationwide footprint. So the recommendation was to find a way to kludge all these networks together into effective nationwide coverage and effectively have a national mesonet. So that's where the program arises, and then Congress took notice and established the program in the Weather Service in 2009, and I was recruited to come run the program, and here I am 13 years later. So next slide, please. This is a bit of a PR slide, I guess. Of course, to us in the Weather Service, the primary utility of a mesonet or a national mesonet effective coverage is for our forecast and warning mission. Everything from real-time detection in the field and bench forecasting operations, forecast verification and validation, also to inputs for initial conditions for our numerical weather prediction systems. But there's a broad range of users in other sectors that benefit from and use Mesonet data. They are all listed here on the left and the beneficiaries on the right. Everything from emergency management to agriculture and water resources to utilities, electric power, etc. All of these users tap Mesonet data to streamline their businesses and operate them more efficiently. Next slide, please. This just shows the locations of Mesonet sites around the USA when we kludge together all these various state and private sector networks. The state-operated networks, if you think of Oklahoma as the example, something like 8,000 sites nationwide across 37, soon to be 40 states now, and a variety of private sector assets and other companies, which in total are providing over 20,000 stations, the Mesonet sites around the country. The states and some private sector companies tend to operate the very high quality networks, which I think are probably more suitable for climate services and applications. And I'll show some examples of that in a future slide. Next slide, please. So how it works is we have all these networks out there, and this is outdated. As I mentioned, there are upwards of 40 now, and they feed their data into the MADIS system. That's the primary operational 24/7 ingest and dissemination system for non-federal data, meaning not from networks that the Weather Service owns and operates, such as our Ravensons, our ASOS, and other networks. All those non-federal data sources tend to use MADIS as their input into our systems and processes. And from there, it can go downstream into various other systems and applications, including numerical weather predictions, in some cases AWIPS. And MADIS itself also serves as a system whereby the field can access, view, and ingest and use the data for a variety of applications. Although I know and I'm aware that AWIPS is the primary tool that field forecasters use. And just so you know, I've been working very hard to try to get Mesonet data fully integrated into the MADIS environment nationwide. I know that some ITOs are very enterprising at the field level and can get that data into your AWIPS locally, but we need a national solution, not just for Mesonet, but as well for other commercial data, such as all the aircraft-based observations, having those SKUTs viewable in AWIPS. Next slide, please. So I'll switch to some examples now, and there are a lot, but I just chose a couple because I thought that they kind of highlight what we can do with Mesonet data. The New York State Mesonet has actually emerged as sort of the gold standard now among state Mesonets. Don't tell Oklahoma I said that. Oklahoma is my heritage, and I was there 30 years ago when they began installing it, and it's certainly a high-quality network, one of the highest quality. New York may eclipse it in some sense because they've installed within their network not just surface stations for surface meteorology, but also a high-quality snowpack observing system, as well as 19 sites that have boundary layer vertical profiling capabilities for wind temperature, moisture, aerosols, etc., with LIDARs and passive radiometers. And with that kind of infrastructure, you can get hourly soundings at 19 stations across the state of New York at high vertical resolution. So it's really sort of a leap forward in terms of state Mesonets moving away from the surface and into that vertical dimension that's all important for a variety of other applications, including numerical weather prediction. So specifically for the snowpack network, the state has engaged in kind of adjusting the snow climatologies that are historically based on federal data. You can take a next slide, please. So very high temporal resolution with all these variables. We now have several years of measurements, and there are many, New York State, it has a wide variety of climate regimes. It's very different on Long Island, which is more like a mid-Atlantic and Carolinas climate than it is in the mountains of far upstate New York, where it's almost an alpine subarctic climate. So it's quite a laboratory to have a network spanning so many climate extremes, and to have a wide variety of observing systems assets where you can sample, archive, and calibrate against other products that were produced historically with our own federal observing assets. Next slide, please. So you can see here with New York State and the Mesonet data, recent climatologies of snowfall with much higher resolution than what you see on the lower left, which is based on historical federal data and representative of 30 years. Of course, the state has a lot longer to go with matching that 30-year record, but the maps show what can be done with higher resolution and fidelity when you have a high resolution snowpack network. And I'm unfamiliar with the details, but I know that this sort of information is important for climate services and products work done by the Climate Services Division with our partners in NCEI and in Asheville. Next slide, please. So switching gears, and this is probably a more germane example that will speak to a lot of you who are out there in the field. Just to recap, Oklahoma, 120 sites covering all 77 counties, high-resolution meteorological profiles, as well as subsurface, soil moisture, soil temperature, things like the 4 components of the surface radiation budget, and in some cases, some surface flux towers that measure the evaporation and sensible heat fluxes from the surface. And they have a long-term archive in Oklahoma that goes back to 30-plus years now. So next slide, please. One of the interesting things that Oklahoma has done, the Mesonet, in partnership with the forecast offices in Norman, Tulsa, and Amarillo, is they have integrated Oklahoma Mesonet data into the co-op network and the climate record. And one way they go about ensuring high quality data that's up to that task and those products and services is a very high quality calibration lab. And you can see there how the specs on how the rain gauges and temperature sensors are calibrated with high fidelity over a large range of temperatures that you might expect to experience over the climate record, and the fidelity that you need to resolve the climate signal and the global historical climate data sets. Next slide, please. And continuity. So they've installed a few sites where, you know, in the practical operation of a network, sensors and sites are going to change, sites are going to change location, but for the long-term stable climate record, such as those sites, you know, we have in the co-op program that have been there in some cases for decades, maybe a century. You need long-term continuity in the siting. You know, if you move it, the land cover changes, the topography changes, other things change, the infrastructure around it may change. Those things are going to have a bearing on the climate signal. So in Oklahoma, they set up these five sites, continuity stations with high long-term stability, where when they do swap outs of instruments and locations at other sites, they have these 5 sites that are representative of the terrain of Oklahoma. And you can calibrate against how that might impact the climate record if you continue using that data forward after you have changed sensors or moved a site. Next slide, please. So this actually predates the time, you know, my management of the National Mesonet Program. This was forged by the Mesonet down there in cooperation with those 3 WFOs that I mentioned previously. And I believe the Ocals and other observing system staff at all those WFOs, 4 of them actually, including Shreveport, were involved. And you can see what the sort of bureaucracy and logistics are there. I won't read it word for word, of integrating these Oklahoma Mesonet sites into the co-op network and the official climate record. So I think that this is probably you know, a straightforward, practical way that Mesonet can serve the climate record. From my own perspective, as I mentioned a moment ago, you know, I'm aware of the long-term legacy historical record in the co-op network, and there's certainly no plan or anything else to try to displace those very valuable elements of the climate record. This is to add to and supplement beyond what we have. Next slide, please. So this just goes into some process, hard copy 891, how the infrastructure is categorized, how things are integrated into weather coder, maintenance once a month to ensure consistency and quality with weather service standards for the Oklahoma Mesonet data and the climate record. Next slide, please. And I think I've already highlighted most of this. One thing I should mention, and I didn't go into it here in detail, Chris Febrick at the University of Oklahoma actually did his doctoral dissertation on this topic. And it's interesting because as you all know, the co-op network is Tmax and Menne and daily precip. And NCEI has a whole complicated and complex and comprehensive system of equations and statistics whereby, you know, they adjust those observations for the climate record, because there's a wide variety of reasons why the observation is taken at a certain time, reported at a certain time, and it can be, offset from what the actual max and min was. And those statistics and those equations have been utilized operationally at NCEI for a long time, developed by Tom Carl. And what Chris showed with his dissertation is that the 5-minute data, the data from the Oklahoma Mesonet is every 5 minutes. So you're highly likely to capture exactly the max and min and when it occurred. And what he showed was that not only is there nothing wrong with NCEI's adjustment techniques, to the contrary, he proved that Tom Carl's methods were quite accurate. So I just thought that's an interesting story to share. So as I've said, the National Mesonet continues to grow, with most states are soon to have a state-operated Mesonet, most of them high quality in the Oklahoma model and suitable for climate applications. Also coming along with very comprehensive metadata about the precision and accuracy of the instruments, the terrain, the topography, the maintenance record, all those things that you need if you really want to bring fidelity to the climate record. And it's archived for the long term, and there's precedent in NOAA climate applications. Next slide, please. And that may be it. Yes, it is. Thank you.
Okay, thank you, Dr. Marshall. Our next speaker up is going to be Dr. Matt Menne. Dr. Menne works in the Dataset Section of NOAA, NCEI, and he joined NCDC in Asheville back in 1998 as a Ph.D. student at the University of Wisconsin-Madison under NOAA's Student Career Experience Program. He works in quality control, data homogenization, and data integration, in support of NCEI's land-based datasets and climate monitoring activities, in particular as the technical and scientific lead for the GHCN datasets. He also serves as the director of the World Data Center for Meteorology in Asheville. Dr. Menne, it's all yours.
Okay, great. So I'm going to go over some criteria that we have come up with for how we include non-NOAA network data in GHCN, and in particular, what might be the future of including Mesonet data into our data sets. So I'm going to start off here with some background, because it turns out that we have been approached by different states over the years about the possibility of including their Mesonet data in GHCN so that it would go into the Applied Climate Information System run by the NRCC and get into different products at NCEI and be more widely available to users. Some of the motivation for that has been the decline in the number of co-op stations, in particular Delaware, which was down at one time to 1 station. I don't know if that's still true. But so far, we really haven't added state Mesonets into GHCN Daily in particular, but we have integrated a bunch of non-NOAA sources over the years, including SNOWTEL, COCO-RAS, the RAS Observing Network, and then a whole bunch of international data, including data from Environment Canada, the Australian Bureau of Meteorology, a number of European Union countries, and so forth. But this is these are sort of national networks and not Mesonets. So to do that, we've sort of used ad hoc criteria at NCEI to decide whether something warrants inclusion and if we should put in the resources to maintain that integration. And it's been primarily based on the community inputs and desires for adding networks. But several years ago, we tried to be a little bit more formal within NCEI and come up with a set of criteria for that we could use to integrate networks and to see if they're fit for purpose. And as usual, there's the caveat that anything we take on we have to have the resources to maintain that over time. But for those who may not be as familiar with GHCN Daily, just a quick background. So it's a global summary of the day data set. So it's just once per day observations based on over 30 different static and active sources. There's about 14 active input streams that come into it. So it includes the co-op data and ASOS, AWOS, the COCO RAWs that I mentioned, SNOWTEL, RAWs, all of those, and a bunch of different international sources. So it gets updated once per day. And although it's an international data set, it's really the focus of our summary of the day processing and QC at NCEI. So it's the nexus of the US system that we have in place. And I know many of you are familiar with the DATZilla process, which is a ticketing and resolution system to track and resolve data issues. You know, Brian Korzinski, he's been the DATZilla gatekeeper for many, many years. And it turns out there's about 3 DATZilla tickets resolved per business day at NCEI. So it's a really active thing. I know for many tickets seem to languish for months and even years, but eventually we get to them all. Some take longer than others to go through the forensics and try to resolve. And then GHCN Daily feeds into the ASA system, all the NCEI publications. If the data need to be certified in a legal context, GHCN Daily is used for the daily data, and then it feeds into a host of climate monitoring products. And the current version has, it's actually over 123,000 stations worldwide, very much dominated by North America, in this case, in the US. And about a third of those have some kind of regular updates. Many of the stations are static, just historic stations. And for all of those 14 feeds, there's a variety of push and pull mechanisms that we have in place that's sort of run by a big master script at NCEI. So every feed is unique in a sense. Some we get over NOAA port, some we have special feeds just for GHCN Daily. So these are the criteria that we've come up with and what would be relevant for integrating Mesonet data. So one is the data policy. There should be no restrictions on the use and reuse of the data. For inclusion, there should be an automated process in place for us to collect and be able to distribute the data on a routine basis. And ideally, this would be once per day for daily updates. And then we also need access to the entire period of record for the source of the data for that particular network, so that we can periodically resynchronize the entire database in case there are changes made to the deeper past. This is what we do for most of the data sets within GHCN Daily, including COCO RAWs. So if there's a change made to data from years ago, we want to make sure that we can resynchronize the source data with GHCN so that users won't get different versions of the data if they access the data outside of GHCN from its home archive. So we also need a network representative who's accessible and available to resolve issues with our data transfer or any quality questions that might come up, so that we're not struggling to figure that out on our own, especially for networks that are managed outside of NOAA. This is critical. And obviously, the network has to provide something that the community considers valuable, that it will actually offer something to the database in terms of downstream products. Usually that's just, as Curtis was just showing, like better spatial or temporal resolution of different climate variables. And then we also need some basic set of metadata for each observing station. And at a minimum, this includes, of course, the location, elevation, but also instrument type and observation time. And all of this stuff can be integrated into Homer, but we need to be able to be current on the metadata for the network. And then these are just what we wouldn't consider mandatory, but certainly are suggested. And I think some of you may know that the AASC has come up with a whole set of criteria, a guide for managing mesonets. That's sort of beyond the scope of what our criteria for inclusion, but there should be an active training program on the methods of observation and reporting. And then ideally there would be upstream quality control of the data and oversight of that process. And finally, there should be obviously a maintenance program in place, like Curtis was mentioning, to ensure that the observations are climate quality. So for us, the basic steps to include a new network is, as I mentioned, access to the period of record and routine updates. And that can either be a push or pull. We can pull from a site, or the data can be pushed to NCEI. But then on our end, we have to reformat the data into an intermediate file format so that we can integrate it into GHCN. This is often a non-trivial aspect to integrating new data, because all of the network data has its own native formats, which we have to make sure that we translate correctly into the GHCN format. And then we need some kind of a station metadata ingest stream into Homer to make sure all the stations are represented in Homer, because that this is really the glue. It's the metadata repository that holds the observations together. And then we want to have this process for synchronizing the network changes with GHCN. A lot of times this is the addition of new stations within that network. We need to create some kind of regular process where we add new stations as they come online, to make sure that we're staying on top of the network management of the source data upstream. And then, let's see, I'm gonna go somehow, here we go. So right now, GHCN Daily is feeding all of these processes, and we have just now completed development of GHCN Hourly, which may be more relevant to inclusion of Mesonet data. And GHCN Hourly is meant to replace the integrated surface data set, which I think a lot of you are probably familiar with. It's the sub-daily data set at NCEI that was developed by Nealot and others in collaboration with the US Air Force. It's all of the NOAA surface weather observations, sub-daily data flow into ISD. It has a very unfriendly format. So we undertook the development of GHCN Hourly in part to align it more with GHCN Daily, but also to create a more user-friendly format. And this has been a partnership with the Copernicus Climate Change Service of the European Union, because as they started to develop their own climate service, they wanted to have all of the data holdings from international data centers like NCEI to start to build their own database. So we decided to partner with them and co-develop a subdaily data set. And in partnership with them, we've reformatted now over 110 subdaily data sources, many of them static, going back to the 19th century to the present, that can be reconciled into just over 25,000 unique land surface stations. And we've included the CDMP. This is the Climate Data Modernization Program that was a big digitization effort in the 2000s at the then NCDC that was keying a lot of historical data sources that weren't yet integrated into our main data sets at NCEI. And so now we've included those into GHCN hourly. But from the Copernicus Climate Service perspective, they wanted to create a database of subdaily data that would support their reanalysis efforts. And so they really wanted to focus on the subdaily data, which was a good synergy for us since we wanted to redo ISD anyway. So now we've been able to integrate a whole new set of data sources into GHCN hourly. So it currently provides 30 different elements, similar to ISD, just in a more user-friendly format. And what will be coming online in the next month or two will be daily updates provided by a US Air Force feed, and then our own NOAA surface weather observation process, which processes the ASOS-AWOS data. And then we're adding the hourly precipitation network data to it and climate reference network data. There's been a push to get more sub-daily precipitation data into our data sets. And so that's the latest push that we have this year, is getting the hourly precipitation networks in there. And you can see at the bottom here is a link. We're just now starting to get the V1 beta out online. And that is all I have. So we'll turn it over to questions now.
Okay, great. Thank you. Hi, guys. This is Jenna Myers. I'm the organizer. So far, we have one question. So if you guys want to put in your questions for Matt or Curtis, just type them into the chat or questions box. I don't know what it says on your item. But also, Matt, do you want me to? I copied that link. Is it okay if I shared that through the chat with people?
Yeah.
Okay.
And just the only thing that's working right now is the full tarball of all the data. There's a little glitch in our access system for the individual station data, but the link is active and live, and updates will soon be flowing to that. But feel free to email any questions if you have issues.
Okay, cool. Okay, so like I said, I only have one question so far. And I don't know who it's for, what type of instrumentation is used in the this must be for maybe Curtis, is used in the New York State Mesonet to record snowfall and snow depth?
Can you hear me?
Yep, we can hear you.
I believe it's an acoustic instrument for snow depth, the same that is in SNOTEL. That's snow depth. What did you say the other?
Snowfall and snow depth.
They have cameras, and to make it simple, a ruler and a background measurement and a camera visibly seeing what the measurement is. They also have, this is the part where I'm less familiar, snow water equivalent, which that's probably some combination of the acoustic information, the depth as measured visibly, and in some cases, a heated rain gauge that's melting the falling snow.
Okay. All right, thank you, Curtis. There's definitely some more questions coming in, so let me get through them. So the next one is, any chance this person who would like a link to the dissertation paper mentioned in the first presentation regarding methods used at NCEI? Do you have that link available, Curtis?
Not at my fingertips, but I can get. I'll find it. If I can't find it, I'll talk to Chris Febrick and get it.
Okay. And you'll share it with me, and then I can, or Chris, or.
Yeah, sure. He may also have some PowerPoints or journal articles that are a little more digestible than his entire dissertation. So.
Okay, great. In our area, the Weather Underground Mesonet network is by far the largest, despite issues with many poorly sited stations. Is there any potential use for this data at the national level?
Is that for me?
They didn't say. Weather Underground.
Well, I can say that we do not buy that data in the National Mesonet Program because it's backyarders and has quality issues. And we only buy the data. We only buy data in the National Mesonet Program from high quality state operated and private networks, and sort of crowdsourcing backyard thing doesn't meet the standards that we have in the contract for quality data. And I would assume, therefore, if it's not even suitable for our, forecast and warning mission in the short term, it's not suitable for climate applications.
Okay, Matt, did you have anything to add for that one?
No, I mean, I think it goes back to what we would consider our criteria, that there's a certain set of observational standards, I think, that have to be met before we'd include it, because you want to make sure it's fit for climate purpose. And it has to be freely available. And I don't know if that data can be redistributed and used freely.
Right.
Yeah, I don't know either. I can say the ones that we buy in the National Mesonet Program by contract, we generally are forbidden from redistributing the raw data to, say, other private sector users who would otherwise pay the networks for it themselves. But any products and services that utilize the data can be freely distributed. And the raw data can be shared with affiliates, research partners, etc. It's just generally don't provide the raw data to anyone who's going to turn around and commercialize it for their own purposes.
Right. Okay, so moving on, we have 3 more questions. Montana's Mesonet network is young and growing. How can I, as an OPL, begin the process of knowing if our Mesonet is being considered by NCEI for ingest into GHCN daily? And if not, how do we begin that process? So I don't know if that one's more for Matt.
Yeah. Well, we haven't been approached by that network in particular. I think, as there's a number of maturing state networks, what might be done in the future is, if the data are considered free to redistribute to whomever, and we have these other criteria met, if we had an ingest where we could glean multiple networks through the MADIS process or something, where we can redistribute the ones that we are allowed to redistribute. I mean, it's one of the reasons we haven't really done much with the MADIS data, is because there's such a variety of data restrictions and policies in that data. But it certainly would be, what I would want to avoid is having a different ingest stream from every state that we have to maintain and interact with.
All the state Mesonets that are part of the National Mesonet Program are in MADIS. So,
yeah, that makes it attractive for ingest. We would just have to differentiate the ones that we would have a redistribute policy.
Yeah, I'm happy to work with you on that.
Okay, I'm gonna share my screen again because I wanted to show the website. Hope this is working. Do you guys see? Oh, there it is. Okay, so this is the website. I put the link in the chat box. This is the website where we post our seminars afterwards. I just wanted to share that real quick. But we have 2 more questions. If we can get through them, I guess we still have a little bit more time. This question is for Curtis. Can you elaborate briefly on the relationship between MADIS and Synoptic Data Group out of Utah? Do they ingest data and then pass it into MADIS? Do they access MADIS data and then add value to it?
May I ask who's asking the question?
Yeah, sorry, that's from Victor Murphy.
Oh, okay. Hi, Victor. So Synoptic is, you might say, the first among equals of all the 50 networks that provide data via the National Mesonet Program. And they ingest all the data from all the various states and private companies. And then they provide it as one pipe to MADIS, rather than MADIS having separate connections with all 50. So they do that, and as well as manage at a subcontracting level the compensation and business arrangements with all the 50 networks. And the portal whereby they do that is something that looks like MADIS, that's upstream of MADIS. And it was actually developed in partnership essentially with the University of Utah and partnering with them in retrofitting MesoWest. So Synoptic's portal is now essentially MesoWest. And I don't understand the innards of it, but there are servers in Western region and between MesoWest and between Synoptic APIs. It's a bit knotted up. But in the end, that's the role that Synoptic has, is that they essentially formed a business with John Harrell on the basis of MesoWest.
Okay, great. Thanks, Curtis. We get the last question here. When data are freely open to everyone, including private, our Mesonet found others were selling their data. This was very problematic for them because they need to sell data to maintain the equipment. I don't know if that was if that was the question. It was at the end of the, hold on. I'm trying to make this a little bit bigger. Nope, I guess that was it. Maybe that was just a comment then. Does anybody have any other questions for Matt or Curtis?
Yeah, I have a question. This is
Sure.
Chris.
Oh, go ahead, Chris.
Yeah, so I guess my question for Matt is, we've heard a lot, and I've heard a lot too, of the approaches from the different states, about getting their Mesonets into GHCN over the last 3 to 5 years in particular. And I know a lot of talk at the ASC meetings even about they're having a Mesonet committee and having their own baseline standards and stuff. Do we have any idea from our end what the timeline on that is? If that's really what the holdup is to getting the states that want to get their Mesonets into GHCN, and even if that gets squared off with the ASC, what kind of a timeline we might expect to see before any data would even flow in any format from even the earliest Mesonets into GHCN beyond COCORAs, because technically that is already in there, and along with the temperature data from the SNOTEL sites and the raw sites, that stuff already is in GHCN for people who aren't aware.
Yeah, I mean, it is interesting because what's happened is we get this initial interest, and then we never quite get around to the specifics. So we've been approached by Illinois and Delaware, for example, and we, from our perspective, we're ready if these. I mean, we developed these standards more specifically when Delaware approached us. So we're definitely ready if a state is ready, as long as we, can get the whole period of record and the license part is okay, if it's been considered free and unrestricted.
Would they have to work out an MOU with NCEI, or would they have to, as far as like licensing, what would that involve then?
Well, CocoRods and others, they just, in the Creative Commons, they come up with their own public domain or Creative Commons license for the data redistribution. But there could be an MOU developed between us just saying, you know, that they intend to keep providing a data stream, an update stream to us. But it doesn't have to be that formal.
Gotcha. But that has to have to be for all elements, like for example, because GHCN is just temp, precip, snow. Like if they have stuff like a soil moisture network or wind data or whatever, if they say like that data is more, you know, profitable to sell and they didn't want to provide that to NCEI, they could still actually, I guess, randomly select what elements they would want to give to NCEI for free to put in.
Oh
the
yeah,
GHCN.
for sure. If they,
Okay.
right. Yeah, if there's other stuff they want to restrict,
That's
they could filter it however.
Okay, so it sounds like really more of the holdup then, if there is a holdup at all, is really the states either figuring out what they want to do themselves, or whether they're waiting to baseline things through the AESC. And then, you know, I heard rumors of that too, that they were trying to go through the AESC, get like a bundle between a bunch of the Mesonets that are in this AESC Mesonet, you know, program or committee or whatever, and then ship all of them to NCEI as like one lump thing. I don't know if that's, you know, something that's been discussed with you or not, but that's something at least I seem to recall some conversation at some, you know, meetings and stuff like that over the last, you know, few years.
Yeah, that was my understanding of where it was headed, but now I haven't heard anything in very recently about that. But that's what would be ideal for us, is to have it bundled in some way. And for example, like we could our ingest stream could be through MADIS, and then we would work with the different states to get, you know, say a period of record periodically. But something that's already in a common format means that we don't have to develop separate processes for every state.
Okay. I have one more question for Curtis, actually. You know, a lot of offices, particularly, I worked in Western Region for 9 years, so MesoWest was a popular display tool in offices. The old called Roman site way back in the day, dashboard, and a lot of people now use the maps, and a lot of it's plotted into AWIPs and stuff. Are there a lot of stations in MesoWest that are not a part of MADIS, or you know, how is that? Because I believe in the past you could directly contact MesoWest and ask to get Mesonets added in, and I don't think that may required that they were in the National Mesonet, or am I wrong about that?
No, you're right. There's a lot of stuff in MesoWest and MADIS that is, you know, backyards that are not procured by contract in the National Mesonet Program, like what's it called?
Co-op?
Yeah, well, co-op, but the other thing that was developed at GSL, it's backyards, you know.
And there's a lot of weather observing program.
Co-op, yeah. So there's stuff like that. There's hobbyist networks. There's states, or I'm sorry, there's counties, municipalities, utilities, small networks, generally probably of lower quality that are not part of the National Mesonet Program. I'm not sure, you know, Synoptic, their API should clearly designate which are which. I think MADIS, just for legacy reasons, doesn't necessarily tell the user what's National Mesonet Program and what's not.
Thank you. I guess one more follow-up point to bring up too, you know, a lot of times we've seen research projects get funded, and as part of the funding, sometime in the field, they'll develop a small Mesonet in response to that project. And it may, you know, these are very small. They're often localized in a small area. A lot of times they're funded by the university or some kind of, you know, research institute. You know, out west, Desert Research Institute was a big one for this. And they'll deploy a network of, say, maybe as small as 5 or 8, sometimes as large as 20 or 25 stations. They may be just as little as temperature data. It may be a, you know, a full-fledged weather station. What would, you know, a lot of times the issues with those is that they're only meant to last for sometimes 3-5 years to support the research findings, and then sometimes the data stays online I know MesoWest would ingest it and stuff like that. But I mean, if the data was to go beyond a certain period, to go in the National Mesonet Program, you're pretty much looking at data that's going to continue infinitely. Like we wouldn't be looking to try to screen capture data sets that are only going to last, like, say, 5 or 10 years or even maybe 30. Am I correct about that?
Yeah, I mean, it's just on a case-by-case basis, I guess. You know, to be included in the National Mesonet Program, a network has to be stable, high quality. It has to have capital funding and sources of revenue, because we are not paying the full operating cost of any of the networks. On average, they're going to get 10 to 15% of their operating budget from the National Mesonet Program. So in order to be eligible for that, both as a matter of being stable for our own observing systems purposes, including the climate record, as well as to be sustainable in a government contracting paradigm, there has to be some assurance that they have baseline capital funding, other sources of funding, and that they're there to last.
All right, thank you. That's all I had on my end. Thanks.
Okay, well, as you guys were talking, we had 3 more questions come in. Hopefully they'll be quick. We have about 9 minutes left. Let's see. What state Mesonets is NCEI currently using in GHCN-D? I think that's for Matt.
Yeah, so we don't have a specific state Mesonet incorporated yet. We've only been informally approached to include them, so we haven't actually included a state Mesonet yet in GHCN.
Oh, okay. Is there a procedure to get sites added into MADIS? I don't know who that question's for.
What was the question?
Is there a procedure to get sites added to MADIS?
Sites?
Sites, yeah.
Yeah. Contact the MADIS help desk, and then usually it circles back to me. And the way things work now is, first they will go into Synoptic, because we've sort of put a hold on adding new sites and networks to the operational MADIS system. But first they will be added to the Synoptic system, and then eventually from there into MADIS.
Okay, so you said to contact the MADIS help desk. Is that online?
Yeah, it's on the madis.noaa.gov webpage.
Okay. Last question. Are there HADS sites included in the National Mesonet Program? HADS.
HADS is not part of the National Mesonet Program. It's federal data, and the National Mesonet Program only involves non-federal private state data. However, HADS, the system, the ingest and dissemination system, operates inside of the MADIS framework. Not part of the National Mesonet Program, but part of MADIS.
Okay, all right. I don't see any other questions. Chris, did you have any other? Or actually, Chris, I'll give you last word, Chris. But before I do, just as a quick reminder, this is the website where we will post the recording afterwards. Jim Z will do that in the next couple of days, hopefully. And then just for a plug for our future webinars, we're skipping February. March, we will be doing a similar showcase that we had last fall with the Winter Outlook Showcase, but we're going to be doing it for the Spring Flood Outlook. And we'll be doing that in March, where several local offices will share their best practices for IDSS for spring outlooks. So that'll be coming up in March, and Chris actually is helping me. Chris and Andrea Bear from Western Region are helping put that together, so thank you. And I guess just thank you to our speakers, Matt and Curtis. Thank you so much for agreeing to do our Climate Services Seminar Series. And Chris, I'll give you the last word to end the meeting.
Yeah, I want to thank both Matt and Curtis for joining us today, and everyone that participated. I think this has been a topic that's been desired by a lot of the offices, well beyond climate. I think there's been a lot of desires from SUs, et cetera, to find out more about this information. So I want to thank both of you for your time and putting these presentations together and reaching out. And I think one thing we need to find out, I think an action item at some point, is for us to get with some of the people from the ASC Mesonet committee and find out after maybe their meeting in June this year, their annual meeting, if there's any updates on that. I think that's kind of a homework project for us in climate services to kind of find out what their strategy is and where they stand on stuff, because I think it's interesting that it was a very, thing that they wanted to work on, but it seems like it's kind of hit a plateau of which, we're kind of waiting for them to, throw the ball, so to speak, and then NCEI play catch with it and taking the data. So I thank you for, your time and explaining all that stuff to us. This was interesting. So thank you.